This is the video for week 4. So I'm going to go over a bit of the conceptual stuff in the slides, but I'm not going to go through every single slide since you can read them. If you are still confused about function, there's a couple supplementary videos that go over what a function file looks like, how to make one, and how to call one. That's from this lecture as well. There's also a supplemental video on anonymous functions, which you can look at as well. So before we start though, I wanted to go over a bit of how to write code now that your functions are getting a little bit more complex. So this is just a strategy to avoid spending hours on the homeworks. So what I recommend is that you start off by writing out the answer on paper, and there are worksheets that can help you do this that are in the homework assignment. So you work it out on paper, you write out the first few numbers, write out the first few actions, and make sure you understand what it is you're computing first. If you can't figure out what you're supposed to be doing, then write down where you're stuck as best you can, and then either take that question to a TA or find somebody to go over with it, or sometimes even just wait overnight and the next morning it'll be clearer. Once you've got it written out on paper, code as small amount as you possibly can. Don't try to code the whole thing all at once. Then my biggest recommendation is run it in the debugger. Don't just press run and hope it does the right thing. Run it in the debugger and go line by line and check what's happening against your paper answers. If it works, good, go back, add the next bit. If it doesn't, if you aren't terminating your loops properly, or your branches you're not going the right way, you're getting the wrong values, take a look at what's happening. Sometimes it's an obvious fix and you can just go back like you forgot the dot times. If it's a little bit more complicated, then check that answer against what you're doing on paper, and sometimes that will help you find the bug. If nothing obvious is coming to mind and you're still stuck, again, write down where you're stuck, write it on a piece of paper, put it in your pocket, take it with you, and move on to the next problem. And then go see a TA or find a friend to talk over with it. So don't try to just keep hammering your head against a brick wall because you're not going to get anywhere. So write down where you're stuck and then keep going. So that's my recommendation for coding for the next few weeks. Okay, so functions. Why are they important? What are they? So the basic idea is a function takes in some input and it produces some output, and you're encapsulating functionality inside that function. What you're hoping is that you write it once and you get it right. So what happens over time is that you have a single file or a single function that has some functionality. You stick them together so you can have functions that call other functions, and you can have functions that call lots of functions and encapsulate more functionality. And if you keep doing that over time, you end up with a much more complex program that's still understandable by being able to go into little pieces and see what happens. So that's what a function is. It also is a convenient reuse of code so that you're not rewriting code all the time. Every time you cut and paste code, it tends to go poorly, and then you introduce bugs. So the more you can put your code in one place, check that it's right, try a bunch of things and make sure it's correct, the better off you are. And you've seen functions already. So sum, min, max, cosine, length, fprintf, those are all functions that MATLAB has written. Okay, here's an example. You can go through this example in the slides. It's also in the scripts, so you can see what's happening in a little more detail. The next little bit I want to go through is what is actually happening inside of a function. So a function is really a wall. Your script that you call is on one side, and the function that you are calling is on the other side. Your inputs are basically thrown over that wall to the function, and then the function throws the output back over the wall. So you have some function here, y equals function of x. That input x gets passed to the function, but everything else that's in your script just disappears. All that happens is your x gets passed over to the function where it can use it. It computes something, it stores the result in an output variable, and that output variable is thrown back over the wall, and then everything that you computed in the function other than that output just goes away. So this way you can have variables named the same on either side of that wall, and they aren't actually the same variables. So that confuses some people. So when you say y equals func of x, even if your function has an input variable named x, those two x's are not the same. MATLAB copies the value from x into that function name, but it doesn't necessarily say, oh, I know that x in the function is the same as that function. Is the same as that x in the function over there. So that's one of the caveats of functions. So here's it in a little bit more detail in MATLAB. So you have your calling scripts. So you call your function from lecture with -2. What's going to happen is that -2 is going to get copied over into that x value where it gets set to -2. Some calculation happens, and then y gets set to some value, and that y value gets thrown back. y1 is the name that we call the thing that comes back. Y is the thing that gets thrown over the fence. And you should remember the variable names, MATLAB doesn't care. You could call these foo and bar. What happens, the value from y gets thrown back over the fence and put in for the value of y1. Okay, so we're going to go skip through some slides. You should go look at those. An example of using a function to do some plotting. So some subtleties of functions. So you can call functions from within functions. So that's a good way to break up functionality, and you'll do this in your homework assignment. So you make one function, you can call another one in there, as long as all those functions are in the same folder. MATLAB will let you use the same variable name for an input and an output. So if you see here, we've got function xy equals myfuncxy. This works, but please, please, please don't do it because it's really unclear to the person who's reading the function what's happening. So instead, label these things x in, y in, because these are input values of x. Then label them x out and y out because those are the output variables of x and y. So here's a few slides on anonymous functions. They're very similar to functions in function files, so go look at those real quick and then come back here. So the difference between anonymous functions and function files is that they are basically variables. They don't need to be in the function file, and they only exist when they're created, and they disappear when they're clear, just like all other variables. Okay, where people get a little bit hung up with anonymous functions is that the variables in the function hide the variables in the main script. So here we have y equals at t 4 times t. This t is going to be set to whatever you pass y. It is not this t at all. These two are completely unrelated. You could rename this t2 or t3 and call this t2 or t3, and the function would behave exactly the same. So in this case, if you call y with 7, this evaluates 4 times 7. It does not evaluate 4 times 3. So there's some other subtleties of functions here. So you can use existing variables. So now in this case, I have at x, so it says x is this local to this function. But here's t. So in this case, because t is not here, MATLAB is going to go look over here for the value of t and put it in here. So when you call this function, it's going to set x to be 7 and it's going to set t to be 3. So this is a little weird. It's got its uses, but for the most part, you will not be doing this. It's a little bit dangerous. There are 1 or 2 cases where it's useful, but by and large, this is not behavior that you want. So changing t, by the way, in this case is not going to change what happens. So we have this function right here. If we change t equal to 5, it's still going to use this t equal to 3 value here. So you read this as take the value that's in t right now and copy 3 in for me. So this has no effect. So y of 7 still evaluates to 7 times 3. Well, there are uses for this behavior. It's often unintentional, at least initially, and you can really get some enormous confusion. So think of a typo where you accidentally did y of little t equals capital of T. You kind of think this is the same thing, but they're not. They're different variables, and MATLAB will complain. One other little subtlety is that MATLAB does not check for the correct syntax until the function is called. So if I do y of t equals 3 of t, you're not going to get an error here. When you call the function, it will then go try to evaluate this and go, oh, oops, I have no idea what to do with 3t. So just beware that you are not going to get errors with your anonymous functions until you actually call them. One other subtlety is that these are variables. Anonymous functions are variables, just like any other variable. So when you call clear, they go away. If you declare it here, it's valid for down here, but it's not going to exist up here. So there's a little more on anonymous functions in these slides that you should go through. And if you think you understand this, come back to this concept checkpoint and see if you can actually get the right answers with these. So this is all about which variable are you actually evaluating. So in summary, functions can be saved in function files. Some tricks with this is you can have some multiple inputs and multiple outputs if you want. Only the variables input1 and input2 will exist inside the function. Nothing else exists inside the function when you call it. So all those things in your script don't exist. Your function must be named the same as so the name of the function here and the name of the file that it's saved in need to be the same. And you can call any function that is in the same directory. You get something where MATLAB can't find it, that probably means your script is not in the same directory. If you get something like MATLAB can't find that function, then that probably your function script is not in the same directory as the one that you're calling. And you must set your outputs on the way back out again. And it's the order of the inputs here that matters, not what their names are. So anonymous functions, very similar, except you can only have one output, and the equation must fit on one line. The other trick is you can actually access variables declared here before you call this function, but beware that that can have some unintended behavior.